Hello everyone. For this week, we will talk about sampling. Okay, so MM is an activity I always do with in-person sessions, and I distributed MM chocolate to the students, and we play a game and show how sampling work. Since this is not in person, I would like to share the link of this activity. It's marked on this slide, and I hope like we have the opportunity to do the activity in person, but this web is very useful to learn about this activity and why we do it. Okay, so let's chat about that very important concept called sampling. So imagine you are throwing a party, not just with your close friend, but think bigger. You've got hundreds of people invited, but you want to get a vibe check. You cannot ask everyone, right? That's where sampling comes in. That's your sampling frame. And now, in the perfect world of research, we use what we call probability sampling. That's like picking names out of a hat to decide who we should ask. Totally random, no playing favorites. It gives everyone an equal chance to voice their party tune preference. But here the kicker. Sometimes picking names out of the hat is not practical. Maybe the hat is too big, or some folks at a party are just too hard to reach. In social work research, where things are as real as they get, we cannot always wait for everyone to throw their names in. So we turn to non-probability sampling. This is like choosing people we can actually find or who volunteer because they really want to dance with their favorite beats. So remember, sampling is our research party hack. It helps us get to low down without needing to pull the entire dance floor. And whether we are randomizing or not, we are aiming to keep the party jumping for everyone. So let's kick it off with what sampling is all about. So sampling, imagine this is you have a population of interest and to whom you want to generalize from your results. For example, you are interested for all the doctor in Canada, or you are interested your school children in Ontario. So this is the population you are interested. And then because you cannot sample the whole population, your interest population, that's why you need to sample a certain portion of the people from this interest population. There are major steps in selecting a sample. So step one is to prepare to make sampling choices. Specific preparation should be made before making sampling choices. Such preparation should include a careful review of the purpose of one's study, the nature of the population, available resources, research design consideration, and ethical or legal issues consideration. And step two is to choose between taking a census and sampling. The second step involves choosing between selecting the entire target population, for example, taking a census, or selecting a subset of the target population is called sampling. In making this choice, it's important that one has a good understanding of the difference between random sampling error and systematic error. Step three is to choose between non-probability, probability, or mixed method sample designs. Once a decision is made to sample, the next step involves choosing between the two major types of sampling, non-probability sampling and probability sampling. Step four, choose the type of non-probability or probability design. And step five is to determine the sample size. Having a chosen specific type of sampling design to be used to select a sample, the next step involves determining of the number of elements to be selected. And step 6 is to select the sample. The final step involves implementing one's sampling choices. The quality of the resulting sample is dependent substantially on the first step, preparing to make sampling choices. There are two general approaches to sampling in social science research: non-probability sampling and probability sampling. With probability sampling, all elements, for example, persons, households in the population, have some opportunity of being included in the sample, and the mathematical probability that any one of them will be selected can be calculated. To compare non-probability sampling, population elements are selected on the basis of their availability. For example, they volunteered, or because of the researcher's personal judgment that they are representative. The consequences is that an unknown portion of the population is excluded. For example, those who did not volunteer will be excluded. One of the most common type of non-probability sample is called a convenience sample. Not because these samples are necessarily easy to recruit, but because the researcher uses whatever individuals are available rather than selecting from the entire population. Okay, let's talk about this. So convenience sampling. Imagine you are throwing a party and you need a quick guest list. You don't have time to sift through your contacts. So you shoot a message to a group chat that's always buzzing. The first 10 to reply are in. Easy, right? That's convenience sampling. And it's like grabbing whoever is available. It's like if you are on campus and need some quick survey responses, you might snag the first few folks walking by. No need to worry if they are representative of all students. You just need the data. But there's the catch. Because you are not exactly pick about who gets picked, the results might not speak for everyone. If you are only asking morning people who showed up first, you might miss the night owls' opinions. That's like trying to guess the flavor of a cake by only tasting the icing. Sure, it's convenient, but you might not get a full picture. Now let's dive into purposive sampling. Think of purposive sampling like creating a VIP list for an inclusive event. You don't want just anyone there. You want people who bring something special to the table. In research, this means picking participants because they've got certain traits or experiences that are super relevant to what you are studying. It's like if you are looking into the secret world of left-handed guitar players, you won't just grab random folks off the street. You will seek out those lefty strummers because they've got inside scoop you need. Sometimes this approach is even handier than random sampling, especially when you are digging into a niche topic. Like if you are exploring the impact of a new meditation app, you want to chat with folks who have actually used it, not just anyone who can fog up a mirror. So purposive sampling is a go-to move in a qualitative research, where you are more about depth of the information than just numbers. It's for when you want to walk a mile in someone's shoes, not just count the number of shoes in the closet. So next time you are on the hunt for some rich, detailed insights, remember, it's all about getting the right picks in the mix. Convenience sampling is like picking teammates for a quick game of a basketball at the nearest court. You don't scout for the best player across the town. You simply work with those readily available. So researchers use convenience samples to select individuals easy to reach, often located close to them, which simplifies the process but may limit the diversity and representative of the sample. On the flip side, purposive sampling is more like drafting players for a league. You are looking for specific characteristics that match the game's requirement. Researchers meticulously select individuals who provide the depth and richness required for the study. These participants are chosen deliberately because they embody the characteristics central to the research inquiry. While purposive samples may not statistically mirror the broader population, they offer meaningful, context-rich insights. In conclusion, both methods serve different purposes for research. Convenient sampling offers quick and straightforward means of collecting data, while purposive sampling allows for focused exploration of specific phenomena within a target group. So this is one of my publications to show where you can find the information about sampling in the article. So for example, here in the participant, you will see, okay, so participants were recruited from top 50 ranked social work program, and by Follow USA rank report. So this is an example of purpose sampling because we only sampled the top 50 ranked social work program in the USA. We did not recruit the top 51 or top 52. This is related to our assignment. If you are interested to make a comment or discuss about the strengths of the sampling in your thesis, you may find in the article for the limitation section, the authors may state, our study is limited. Our study is limited to top MSW program in the US, which limits our generalizability to both other social work degree programs or other countries. So usually in the article, the authors will say, what's the limitation of their sampling? For here, they only limit to top 50 or MSW program in the US. They did not target BMSW or DSW. So you can borrow the sentences from the article and to elaborate on your own point for the limitation or strength of the sampling. So next strategy is snowball sampling. It's particularly effective in gathering a sample when participants are hard to locate or reluctant to come forward. Consider a study on the experiences of individuals with a rare hobbyist community. Locating this enthusiastic through conventional means may be challenging. So the researcher begins with a few known individuals and then asks them to recommend others who share the same interest, thus expanding the sample progressively. So snowball sampling technique is especially useful when the researcher dives into a very sensitive topic or specialized population, such as undocumented immigrants, where trust and access are significant hurdles. By leveraging the networks that individuals within the target population have, researchers can build a sample that might otherwise be impossible to compare. So this slide is a sample indicator where you can read slow sampling from the article. For example, here, the second sentence, data were collected through a snowball sampling. So this is a part of the data collection to show where what is the sampling method used, and it helps you locate the information you need to complete your assignment. This is another example, like under methods, participants, you will see where you can find the sampling information. So you may pause the video and read this paragraph. This is another sample because this is from my paper, because my research focuses on using social media and use machine learning technique to do research. But it can also review social science technique. So for example, please read the second paragraph. We obtain all available tweets from each user and proceed to his or her followers. And then from each of the followers, continue to repeat the process. So how we collect the data? We collect the tweets from a certain random people, and then because we have their followers list, and then we collect the tweets of their followers, and then we also collect the tweets of the followers' follower, and so on. So this is like snowball sampling. We start from certain participant and then collect tweets from their followers. We use this technique to serve the purpose of our research paper. So if you're interested, you can read my paper to see the whole picture of that study. Okay, next one is quota sampling. So think of quota sampling as sampling a team with players from every position. You are not just randomly picking anyone who can dribble. You want a point guard, a shooting guard, a small forward, a power forward, and a center. So in research, that means you select people to reflect the population's diversity in terms of age, gender, income, location, or other characteristics. It's like you are hosting a dinner party and want a mix of professions. You want some doctors, you want some teachers, artists to entirely lively, varied conversations. You don't leave it up to chance by inviting random people. Instead, you choose guests deliberately to represent different walks of life. So this method is fantastic because when you are aiming for a mini version of the society, giving everyone a seat at the table. But here is the thing, it's tough to be sure your carefully assembled group really speaks for the larger crowd. You might nail the proportions, but there's always a question of whether these folks truly reflect the bigger picture. So as described on this slide, the researcher didn't knock on the random doors. They categorize neighborhoods based on average wealth and then choose three from each category. It's like ensuring you have guests from every part of town at a city-wide gala. Then, for that personal touch, they made sure their sample had equal representation across genders and age groups. It's not just pick anyone off the street. It's about selecting participants who collectively resemble the city's demographic jigsaw puzzle. This slide and the next slide is an activity I always did with in-person session. Excuse me. I read down the whole process, so I recommend you to pause the video and read this slide to show this as an example. Okay, next we are going to turn our attention to probability sampling. Let us dive into its fundamental premise. This methodology hinges on the principle of random selection, where each individual or element stands an equal chance to be selected. The beauty of this approach lies in its impartiality. Every potential participant is given the same opportunity, devoid of biases, much like every ticket in the lottery has an equal shot at being drawn. To implement this in practice, one must begin with a comprehensive list, including every possible respondent within the target demographic. Imagine, if you will, a researcher seeking to understand the impact of a new health policy on the elderly. They would compile a complete list of residents aged 65 and above in a given area. This list serves as a sampling frame from which individuals are selected through a random lottery type process. It could be as simple as drawing names from a hat or as sophisticated as using a random number generator. The key is that selection process is free from the researcher's control, ensuring that each participant is chosen solely by the chance. Employing probability sampling leads to the statistical strength of the findings because it allows for the results to be extrapolated to the larger population with a quantifiable level of confidence. The first step is simple random sampling. It's a cornerstone technique for a whole probability sampling technique. It ensures each individual in the population has an equal chance to be selected. This method is a golden standard for achieving unbiased results in research. The next step is systematic random sampling, which is like having a secret recipe for pickering participants. You start by lining everyone up and then select the every nth person to cook up your sample. It's like those old school raffle tickets at a community fair. You've got a whole row to choose from, but you are only drawing every 10th ticket. So for example, 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. So this method keep things fair because everyone got the same shot as being chosen. But instead of grab a bag like simple random sampling, it's got a rhythm to it, a pattern, a systematic approach. It's a bit more structured, ensuring that your sample is evenly spread out over the whole population. Another one is stratified random sampling. So picture this. You've got a big bowl of mixed nuts, and you want to make sure every handful includes all the different types. So you sort them out first, almonds, cashew, pecans, and then grab a few from each pail. That's what we do in stratified random sampling. First, we split our population into different groups or strata based on characteristics like gender or job status. Then we randomly select from those subgroups. It's not just a free-for-all, it's about ensuring we get a slice from every piece of the demographic pie. Sometimes we might shake things up a bit, not sticking strictly on how many of each group there actually are. Like if you want more pecans in the mix, even though there are fewer of them in the bowl. The whole point is to make sure our sample covers all the flavors of the population, especially the ones crucial to our study focus. For example, we are looking into job satisfaction among social workers. We will want to make sure we include both part-time folks and full-time folks in our sample to see the full picture. So stratified random sampling gives us a tester approach to a research, making sure we get a balanced mouthful of insights from all corners of our population. So looking at this example, let's explore the stratified two-stage cluster sample used in a study conducted in the city of Boston. The city was divided into 12 groups across 4 demographic areas and 3 levels of minority density. This careful categorization ensures a rich diversity within the sample, reflecting the varied tapestry of Boston's population. During the first stage, census blocks were randomly selected from each stratum to give a chance for all areas to be representative in the sample. The next step involves identifying households within these blocks using an up-to-date resident list. This approach exemplifies a meticulous planning process where random sampling is merged with quota sampling to balance. Okay, so this process merged with random sampling with quota sampling to balance representativeness with practice. By selecting areas with different demographic densities, the researchers could ensure a broader spectrum of experiences related to the urinary tract symptoms, and the quality of life was captured. However, it's also important to acknowledge that the response rate, as about 1/3 of the household complete the screening, and attempts to contact household were not always successful. This highlights common challenges in field research, which tell us the need for persistent and robust follow-up procedure. Okay, the next one is multi-stage sampling. Let's paint a picture using a real-world example. Say we are curious about what teachers think about teaching the birds and the bees. Sorry, excuse me for my sounds, it's bees, B-E-E-S, in schools across Ontario. We cannot chat with every single teacher, so we have to break it down step by step. The first step, we pull 5 cities out of the hat. A random pick from all the places in Ontario. We are not playing favorites. Every city has the same chance to get the spotlight. And next, we take a look at those chosen cities and say, let's find 10 schools in each spot. It's like zooming in on a map until you find just the right neighborhoods. And last, we swing by each school and pick 20 teachers who are up to sharing their thoughts on sex eds. So this is not just a roll call. It's about getting a good mix from each school. So this multi-stage approach is kind of like making a layered cake. You don't just toss all the ingredients in a bowl. You assemble in pieces by pieces to get a full flavor. By the end of it, you've got a sample that's like a snapshot of the bigger picture, perfect for figuring out the patterns without needing to knock on every teacher's door in the province. Okay, so when considering multi-stage sampling for your research is like planning a journey with multiple layovers. You don't just think about the destination, you always plan each stop along the way. First, ponder the size of your population. It is a cozy village or a bustling metropolis. The larger it is, the more you need to structure approach to ensure its representativeness. Cost is a big deal, of course. Large-scale surveys can run up quite tight. Multi-stage sampling is like budget travel. It's cut cost without cutting corners, allowing for logistical simplicity without sacrificing depth. Always seek out a guide, an experienced researcher with a know how to navigate multi-stage sample design. Their experience is like a map in an unfamiliar territory, help you to avoid pitfalls to ensure your research stay on the track. Okay, so remember, the golden rules of sampling still apply. Ensuring your response rate is as high as enthusiastic shows of hands in a packed auditorium. So every response is a step towards a more comprehensive understanding of your research landscape. This is a screenshot from the textbook to show the sampling technique with example and their advantage and limitations. You may pause the video and read it through as a recall. To go further about sample, we can talk about sample size and sampling error. A larger sample size enhances the likelihood that sample accurately reflect the population, as the law of the large numbers suggests. Okay, so larger sample size enhances the likelihood that sample accurately reflect the population. So the concept of sampling error is integral to understanding the precision of our estimate. Sampling error is a discrepancy between our sample estimate and the true population parameter. If you recall this back to the statistic week when we talk about hypothesis. So sampling error is a discrepancy between our sampling estimate and the true population parameter. It is inherently to the sampling process and decreases as the sample size increases. In other words, the larger the sample, the smaller the gap between our estimate and the actual population value, reducing the potential for significant error. So for instance, if we take a sample of 100 individuals in a city to estimate the average number of hours they spent on leisure activities per week, there's a certain margin of errors associated with this estimate. However, if we increase our sample to 1,000 individuals, the margin of error typically decreases, assuming random sampling, thereby providing us with a more precise estimate. So this is towards the end of this lecture. So you are required to know what the difference between probability sampling and non-probability sampling, and what is sampling.